Hi folks, we're going to take a look at page 407, number 3. So here they give us a whole bunch of operations on vectors, and they want us to determine which ones are possible, and they seem to be implying that some of them are not possible. So, they're meaningless. All right, so I just want to remind everyone, what happens when we operate on vectors and what the different operations produce. So if I look here, I see an addition between these two vectors, and I know that the sum of two vectors gives me a vector. Here I see a cross product of two vectors, and the result of a cross product of two vectors is another vector. Whereas in this case here, I see the dot product of two vectors, and I know that what gets produced is a scalar quantity. Okay, so depending on what might get produced with one of the operations will then affect whether the next operation is possible or not. Now, if I take a look at A here as an example, I see that there's both a dot product and a cross product. So when you've got three vectors that are being operated on using products, whether the same type of product or different product, that's what we call a triple product. And there's one in particular that's going to be very useful for us a little later on. But let's take a look here at A. All right. So if I take a look at A, I see that the first thing I have to do, since I've got brackets, is I've got a cross product. Okay, so if I don't do anything with this vector A, but now I operate on B cross C, well, I know that that's going to produce some vector quantity. And I am able to take the dot product of two vectors. And so that operation works. Okay, let's take a look at B. So now if I take a look at what I have in the brackets, which I have to do first, of course, A dot B gives me a scalar quantity. So say I call that K, and then they're telling me to take a cross product with this vector quantity. Well, cross product is defined as an operation on two vectors. So this one here has no meaning. All right, so meaningless here. Okay, let's take a look at C. All right, so in this first bracket, I have a cross product, which is going to give me a vector. And in the second bracket, I have an addition of two vectors, which again gives me a vector. So what I have is out of this first one, I have some vector, and then I'm taking a dot product with C plus D, which is another vector. And of course, I am able to take the dot product between two vectors. Okay, so that's perfectly good. All right, let's take a look at D. All right, so if I look at this first operation, A dot B, dot product of two vectors gives me some scalar. And now notice here, I don't have any operation. So this represents just regular multiplication. Okay, C cross D gives me a vector. And so this is meaningful because essentially what I have is I have a scalar quantity times a vector quantity. So this is just scalar multiplication, which of course produces a vector. So this one is good. All right, let's go to E. Okay, I look at this first operation, A cross B gives me a vector. Okay, and then I'm crossing that with another cross product, which again gives me another vector. All right, and of course I can cross two vectors. So it looks like that one is good. And let's look finally at F. Okay, here I see that I've got no brackets, but I don't think you should be too surprised that we're going to follow the same order as we did previously. Okay, we're going to do the product first. Okay, so A cross B gives me a vector, and then I'm adding that to another vector, so plus vector C, and of course I am able to add two vectors. All right, so in this case here, we have all but B was a reasonable set of operations to take. All right, so again, what you want to do is you always want to think about what gets produced when you operate on two vectors, and then from there, see what happens when you input it into the next operation to see if it's reasonable or not. All right, that's it for this one.